All right, I think it's time to get things started. Welcome to the class. This is Applied Calculus 1. The course is about, an introduction to calculus, meant for people who don't know anything about calculus. Really all you need is sort of high school level algebra. We're going to talk eventually about, limits, derivatives, and basic stuff about antiderivatives and integrals. So I hope you're ready for that kind of stuff. Let's just get started. The first thing I want to talk about is going to be functions and limits. All right, from the comfort of my own zero-budget basement film studio. Functions and limits. Really, the function stuff I think is going to be review for everybody. I'm going to assume that I hope you already know everything that I say about functions. Limits is really the first real idea from calculus that is not really considered to be part of other things like algebra. Limits, in fact, is the basic idea that all of the major concepts of calculus are based on. Although we're really not going to talk about limits specifically all that much, but they are the important foundation of all the things that we are going to talk about. So, functions and limits. First, let's talk about functions. So, really, everything we talk about today is going to be based on looking at graphs and just saying simple things about graphs of functions. Let's say we have a function that looks like this. All right, let's say this is our function, okay? I'm not going to tell you an equation. Like I said, today we're just going to be talking about things involving just looking at pictures of functions. So this is our function, f of x, and it goes through certain points, and I just want to talk about how we indicate what points it goes through. For example, this point right here, let's just go left to right here. This point right here, the x value, it's the horizontal one, is -2, and the y value is also -2. And so for that value right there, the way we indicate this is f of -2 equals -2. That means when the x value is -2, the y value is also -2. All right, how about this one? I hope you know this already. This one, the x value is -1, but the y value is 0. So the way we write that is f of -1 equals 0, right? And so on. Let's just write the other ones. This one right here, the x value is 0, the y value is 2. So that would say f of 0 equals 2. This one right here is x equal 1 and y also equal 1. So that would be, I'll just put it over here, f of 1 equals 1. This one right here, the x value is 2, the y value is 0, so that's f of 2 is 0. And then here I have x equals 3, y is 1, so f of 3 is 1. And finally, this point over here, the x value is 4, the y value is 2. So I'm running out of room here. F of 4 equals 2, right? This is just the way that you say where the y value is. You say f of whatever, the x goes in here, the y goes over there. Sometimes a function can do something weird. How about this? Something weird. I'm referring to places where a function can have a little jump in it. Something like this. In the case when a function has a jump in it, that means the function, it looks like this when the x values are, say, negative, and then 0, and then 1. And then suddenly, when x equals 2, there's this jumpy thing happens in the y value. The value jumps up. This is weird. Most equations of functions don't do that. I mean, most equations that you've talked about don't do that. But in the real world, actually, there are things that act like this, and we are going to talk about these kinds of functions. I just want to talk about the two styles of dots here. Here I drew like an empty point, and here I drew a filled in point. This is to indicate what exactly happens right when x equals 2. It's a little ambiguous. Is which the y value when x equals 2? Is it supposed to be 1 or is it supposed to be 2? The filled in dot and the empty dot are meant to clarify that. The filled in dot is where the y value is. So when you see this empty dot, filled in dot, the filled in one means the y value is here, right? It is not here. That's what the empty dot means. Not here. All right? That's what the filled in dot and the empty dot. So in this example, it is the case, what is f of 2? You go over to x equals 2. You see these 2 dots. Which one am I going to choose? You're going to choose the filled in dot. So in this case, f of 2 equals 2, right? This one, not 1, which is that one. All right, that's what the empty dot and the filled in dot means. There's not a lot to it. Sometimes it can be slightly weirder than that. Sometimes you can have 2 different empty dots, for example. It could look like this and then maybe like that, right? So now this says I have some ordinary looking values over here, and then there's a jump. The y value here is 2, and then it continues on some other curve. How could there be 2 different empty dots? There can be 2 different empty dots. The empty dot says the y value is not here, and it's also not here. It is here, all right? You can't have 2 filled in dots stacked vertically. That's because a function can only have 1 y value. So it wouldn't make sense to fill in, say, all 3 of these dots. That would mean the y value is all 3 of those, which is not allowed for a function. Alrighty. Sometimes there simply is no value. Let's look at one like that. All right, what about this one? What can you tell me about the values here? Now there's ordinary looking values over here and along here. Something weird happens right there. Something also weird happens right here. Let's talk about right here. When x equals 3, what is f of 3? I hope you can do this along with me. What is the y value when x equals 3? Well, I have two options here, but you choose the filled in one. So the filled in one is y equals 0. So f of 3 equals 0. All right, that's where one weird thing happens. There's another jumpy thing here. This is another weird thing. What's strange about this is there is no filled in dot. So in this case, f of 2, what is the y value? It's not here. It's also not here. I guess it's nowhere. There is no y value when when x equals 2. So in this case, I'm going to write it like this. F of 2, I'm going to say DNE. That means does not exist. F of 2 does not exist. There is no y value when x equals 2. All right, little picky thing. I didn't write equals DNE. F of 2 does not exist. That's what that means. If you write like this, f of 2 equals DNE, I know what you mean, but it's like grammatically not correct, right? F of 2 equals DNE. That f of 2 equals does not exist is not. That ain't it, son. Just say it this way. F of 2 does not exist. All right. What else? Oh yeah, there's actually another place where this function does not exist. Do you see it? Another x value where f of whatever does not exist. It is right here at x equals 0. You will see this is like an asymptote, a vertical asymptote, and there is no y value at x equals 0. So it is also the case f of 0 does not exist. Right? All the other values do exist. F of 1 is whatever y value that is, maybe minus 2. But I'm only talking about the weird ones, the interesting ones. All right. All right, that's all I want to say about those functions. I hope that's just a review for everybody, I hope. Really what I want to talk about is limits. Like I said, limits is the basic idea behind basically all of calculus. Limits. The idea behind limit is when I'm asking you, instead of like f of 2, that is, what is the y value when x equals 2, I could ask you, what is the limit as x approaches 2 of the function? So you're talking not about, so let me say lim. When we talk about limits, we write them down using this. We write lim is about nearby values. Not about what is the y value right at this point, but what are the y values close to that point, all right? As sort of a slogan, I would say it's not about the point. Not about the point, but it's about the curve near the point. All right? Usually those are the same. where the point is the same as where the curve is near the point. But in some weird cases, they are not the same, and though the distinction is important. So let's look at a function. This is a simple one where nothing weird happens. This is like an ordinary example. Like I said, usually the two concepts are the same. How about this, for instance, and I have maybe this point here. Let's say this is, in this case, I would say f of 0 equals 2. What that means is the y value right there is 2, all right? It is also true that the limit as x approaches 0 of f of x is 2. We write it this way, lim x approaches 0, f of x equals 2. What this means is that along the curve, as the x values get close to 0, you don't look down here though, you have to look along the curve when the x's are approaching 0. What do the y values approach? They approach 2, all right? Along the curve, the y value also goes to 2. This one means, let me try and, sorry, I have to erase the picture. There's not much to say about this picture. When you say f of 0 equals 2, this means the y value at x equals 0 is 2, right? At that specific point, the y value is 2. What this means, and it seems like I'm saying the same thing, but it's all actually, these are not always the same. What this means is when x is near 0 along the curve, the y is near 2. All right, so the picture again looked like, I hope you didn't erase the picture like I did. You know, something like this. All right, the fact that this dot is right there is really the first one. F of 0 is 2. Right at x equals 0, it's 2. This is about the curve nearby. It says if I'm traveling along the curve and I reach the place where x equals 0, nearby that place where x equals 0, the y values are going to be close to 2. All right, that's what the second one means. Let's look at a case when these are not the same. I keep on saying they should seem pretty similar to you, but they're not actually the same. Let's see. How can it be? This can happen that they're not the same when you have one of these functions with a weird jumpiness to it. Let's say I have something maybe that looks like this, and it has an empty dot and a filled in dot. When you see this empty dot, filled in dot, that typically indicates that the limit is different from the actual value of the function. Maybe it always means that. In this case, so what's interesting here is really when x equals 1. These other points are more ordinary. When x equals 1 here, you can see, first of all, f of 1, that would be what is actually the y value when x equals 1. And it is this point, you choose the filled in dot. It is 3, right? So f of 1 equals 3. But how about this? Lim x approaches 1, sorry, put the wrong number. Lim x approaches 1 of f of x. It's a shame this is such a complicated thing to write. This is how we write this whole idea of where is the curve going. This is where is the point. This is where is the curve going to. When x approaches 1, so you look along the curve in the vicinity of x equals 1, and where does the curve go to? The curve goes to 2, right? The actual point is at 3, but the curve goes to 2. That's the difference. So this one is 2, all right? F of 1 is 3, that means the point is actually up here, but lim x goes to 1 of f of x is 2. That means the curve is actually going to y equals 2, while even though the point is going to y equals 3. All right, at all these other points, the limit and the function are the same. There's no displaced point. But right here is the interesting one in this example where they are different. All right. Here's another related example. All right, I got another example. How about this? What if we have, let's just look at a line like this, but it has an empty point on it like so, all right? What can we say about the values of this function and the limits of this function? Now, ordinarily over here is not very interesting to talk about. I'm interested in right there where the sort of funny business is happening. This is x equals 3. So what about f of 3? And also what about lim x goes to 3 f of x, right? These are the two things that I want to discuss. Now, f of 3, what is f of 3? It means what is the y value when x equals 3? And I can see here, if x equals 3, there is no y value, right? I have an empty circle and no filled in circle, so f of 3 in this case does not exist, right? And what about lim x goes to 3 of f of x? That means you look around x equals 3, but along the curve, does the curve approach some value? And in fact, the curve does approach some value. It is y equals 2. So this one does exist, and it equals 2. All right? So it is possible that one of these exists even though the other one doesn't. Let's check out another one. All right, how about this function? This is pretty weird, but it has an asymptote here, so the values go up like to infinity. But then the value at the asymptote is actually filled in with a point like that. All right, pretty strange, but you know, it is a function. It counts as a function. What can we say about values here? Really, the interesting part would be near x equals 0. So I would like to talk about what is f of 0, and also what is lim x goes to 0 f of x, right? What do you say? F of 0 means what is the y value when x equals 0? The answer is 1. It's this point right here. So f of 0 is 1. What is lim x goes to 0? That means you look along the curve when the x's are getting close to 0. What is the y getting close to? And in this case, actually, along the curve, these there's kind of two pieces of it, and they don't get close to anything. They go up to infinity. So this limit does not exist. Right? The limit as x goes to 0 means what is the curve actually approaching? What y value is the curve getting close to? And the answer is there is no y value that the curve is approaching. There is no y value the curve is getting close to. That means the limit does not exist. All right? All right, this is a wild and crazy example. Let's talk about various values and limits of this function. You can see there's weird things happening all along this picture here. Let's just go, say, starting with this x value and just go across here and see if we can write down what is the value of the function and also what is the value of the limit at each of those whole number x values. -2, -1, 0, 1, 2, 3. All right, let's see. How about -2? What is f of -2? I'm going to try and squeeze these all in right here. I hope your paper is bigger than my piece of glass. -2, f of -2. What do you say? What is the y value here? Well, I see no y value here. That means f of -2 does not exist. All right. How about lim x goes to -2 f of x? This means what if you look along the curve near this point, what does the curve approach? Which y value does the curve approach? And the answer is the y values do not approach anything. It's like the one we just talked about. So this limit does not exist. Okay? All right. How about here? X equal -1. So again, I want to talk about f of -1 and also lim x goes to -1 f of x. Okay. What about f of -1? That means you look at this point. What is the y value? I see the empty circle, the filled in circle. When you want to know what is the y value, use the filled in circle. That would be 3. So f of -1 does exist, and it's 3. What about this? Lim x goes to -1 f of x. That means you look along the curve near this point. What do the y values go to along the curve? They go to this value, which is y equals 2. So this one is 2. All right? I hope you are following along with me. How about right here? This point, x equals 0, f of 0, and also lim x goes to 0, f of x. What do you think? F of 0 means you look at 0 and look at what's the y value here. It is 1, right? Curve goes through, y equals 1. So this is 1. And how about lim x goes to 0? That means you look, instead of right at this point, you look along the curve. Where is the curve going? The curve is also going through 1, and so this is also 1, all right? This here means the point right at that point is 1. This means the curve is going through 1. It's both. They're both 1. All right, how about this one here? Am I running out of room? Maybe I'll just write them down here. This is x equal 1, right? So I want to know f of 1 and also lim x goes to 1 of f of x. What is f of 1? It means right here, you look, what's the y value? I got the empty and the full. You use the filled in value for the y value, that is 1. So f of 1 is 1. The limit as x goes to 1. This is something we actually haven't talked about a situation exactly like this before. As x approaches 1, where does the curve go to? In this case, the curve does not go to any specific values. It kind of goes to two different places, right? Over here, the curve goes to y equals plus 1. Over here, the curve goes to y equal minus 1. In that situation, if you are asked to find the limit, you just say the limit does not exist. There's two different curves here, so we say overall the limit does not exist. Now, there is a way to say, you know, I got one limit on the left side and a different limit on the right side. And we're going to talk about that in a few minutes. But if the question posed to you is just what is the limit, you say, in this example, there is no limit because it's approaching two different values. All right, how about this point? X equals 2, f of 2, lim x goes to 2, f of x. What do you say? F of 2 is what's the y value right at this point? It looks like y equals 0, so this is 0. This limit as x goes to 2 of f of x means where is the curve going through at this point? And it is also y equals 0. All right, and finally, this point right here, let's do it. X equals 3. I got to erase something now. Maybe, can I just do it right down here? F of 3 and lim x goes to 3 f of x. What do you say? F of 3 means right at x equals 3. Where is the y value? Actually, there is a y value right there. It is -1. I hope you said -1. And what about the limit? That means if you look along the curve, where is the curve going to? What's the y value the curve is going to? And in this case, there is no limit. This part is going up there to infinity. This part is going down there to like -infinity. This limit does not exist. All right. This is how we do it. If you were able to follow along and do those yourself before I did, you should feel good about determining limits graphically. One last thing to say, it's sort of a technicality, easy to see on the picture, has to do with these limits on two different sides being two different values. Typical picture would be something like I got a filled in here, say like that, and then it has an empty down here and continues on that way. Okay, in this case, I would like to talk about the limit when x goes to 2. Well, first of all, what is f of 2? What actually is the y value? It's the filled in value, which is 1. What about lim x goes to 2, f of x? This is, where is the curve going when x is going to 2? And the answer here is this limit does not exist. That's because there was one like this in the big one we just did. We really have two separate curves and they're going to two different places. So there is no single y value that this function goes to. But you will agree with me, there is a single y value if we only restrict our attention to points on the left side of this weird spot. They do approach a limit, which is +1, and the points on the right side do approach a limit, which is -1. There's a way of writing that, and here's how we're going to write it. So this says, it's like this. Oops, this is -1. All right, this little plus right here means the limit from the right. So this is limit from the right. This little plus sign here indicates from the right, plus meaning like the positive side of the x's coming from the plus side. You know, the x-axis has these two sides, the plus side and the minus side. So when you're coming from the plus side, which is from the right, the y values along that part of the curve go to -1. Whereas from the left, we write it this way, lim x goes to 1 with a little minus sign, f of x. This is the limit from the left side. So as you're traveling along the curve coming this way, the y value goes to +1. All right, so this is the limit from the left. These are called the one-sided limits. All right, so it is possible sometimes when the overall limit does not exist, because it's going to two different places, you can still say sometimes, where is the limit from the left versus where's the limit from the right? And these are how we write those down. This is the limit from the right, limit from the left. All right, I think that'll do it.